Hi there, Mrs. Thompson here, and I'm going to cover scientific notation today and how to do calculations with scientific notation. So in chemistry, we're going to be dealing with some very large numbers. For example, we work with something called the mole. You don't have to know what that is just yet, just know it's a very big number. Look at all those zeros at the end. We also deal with some very small numbers, like the mass of an electron. So all of those zeros in the front mean this is a very, very small number. If we wanted to figure out the mass of a mole of electrons, here's what we would do. We would multiply these two numbers together. Keeping track of all those zeros isn't something your calculator can handle. You can't just punch in 0.000. It actually errors out. So you would have to line all the zeros up and do this by hand if we didn't have scientific notation. All right, so here's what that is. It's just a method of representing some very large or very small numbers in the form of m times 10 to the n, where m, which is just another word for coefficient, it has this fancy word called a mantissa, but it's just a number between 1 and 10. It can be 1, but it cannot be 10. It has to be somewhere in between there. N is always a whole number, so don't put any exponents that are something like 2.5. It has to be 3 for a whole integer. All right, so we're going to first learn how to change numbers into scientific notation. In order to do that, you're going to insert an understood decimal point. That's if there isn't a decimal in the number already, and that's always at the end of the number. Then we're going to decide where the decimal must end up so that we have only one non-zero to the left of the decimal. Then we're going to count the number of places that I moved that decimal point. And then we're going to rewrite it in the form that I mentioned earlier. And we're going to keep only the significant figures. So we'll do some examples. All right, a couple things to note. When you move the decimal to the left, your exponent is going up. When you move your decimal to the right, your exponent is going down. Here's how I memorize that. I use the mnemonic LARS. Sounds weird, but you'll see me talk about it over and over again. LARS, left is add, right is subtract. So left is going up, right is going down. And you'll see what that looks like. All right, so let's say I'm dealing with this number right here. The spaces in between are just there so we can see every three sets of numbers instead of putting a comma. Okay, you'll see that in your textbook a couple of times too. We're going to first insert an understood decimal point. So that would be right there at the very end of the number. Then we're going to decide where do we put the decimal, where are we trying to move it to, so that we have one non-zero to the left of that decimal point. So let's see, I'm going to put it right there. Another way to look at it is if I put a decimal there, 2.5 is a number between 1 and 10. Then we're going to count how many times it takes to move that decimal point to the new location. It's 9 movements. And then I'm going to rewrite it in the form. So it'll be 2.5 times 10 to the 9. What happened to all of those zeros? Well, all of those zeros were not significant. This decimal point that I added didn't exist. And so the number of significant figures that I have in my original measurement, this one has 2, have to be there in my converted version. Okay, so since it has 2 significant figures, the answer here would also have 2 significant figures. Okay, let's talk about the 9 part of it. We moved the decimal 9 times. We moved it to the left, so it's a positive 9. Bars. Left is add, so left is positive. All right, here's another one. Here now we have a small number. We have all those zeros in front. It's got a decimal, so we don't need to do that first step. we'll skip to the second step. Decide where it has to end up. Well, I want a number between 1 and 10. I only want one non-zero to the left of the decimal. So I'm going to move it to right there. That'll give me 5.79, and 5.79 is a number between 1 and 10. It has one non-zero, the 5, to the left. Okay, now we'll count how many times it takes to move it to that new location. 5 times. We will rewrite it in this form. Okay, so it's 5.79. Notice all the zeros in front were never significant, so now we just drop them, we get rid of them. We moved it 5 times to the right, and right is subtract. Lars, left is add, right is subtract. So when I moved it to the right, it gained a negative exponent. Also, when I'm thinking about this is a very small number, so the exponent is going to always be negative when you have small numbers. The exponent will be positive when you have very big numbers. I just said that here. All right, so we're going to take some things that are in scientific notation and move them into normal notation now. So remember that a positive exponent means that the number was originally big. A negative exponent tells me that the number was originally small. So 5.0 times 10 to the 5th power is probably a big number because it has a positive exponent. Okay, so I'm going to take this number and change it into normal notation. Notice how it says at the top, to go to normal notation, it's like going to 10 to the 0 power. So I'm going to move the decimal to get to 10 to the 0. I want to move it from 10 to the 5 to 10 to the 0, so that needs to subtract in value to get to 0. It's going to need to move 5 times to get to 0. So we'll move it 5 times to the right because right is subtract. And we're using that mnemonic Lars. I moved it 5 times. I need to replace those blank spots with some zeros here. Okay, and so my answer would be 502,000. Let's talk about significant figures. In this number right here, what's significant, and maybe I didn't mention that earlier, is just what is in front of the times 10. So the 5, the 0, and the 2, those are 3 significant digits. When I changed it to normal notation, these zeros don't count because they're just placeholder zeros. So it also has 3 significant figures. So I did that correctly. Good job. All right, another one. Let's say we've got a negative exponent now. What do we do? Okay, well, remember, left is add, right is subtract. So how do I get from -3 to an exponent of 0? Well, since it's negative, I have to go up. So I'm going to have to add 3, which means I'm going to have to move this exponent to the left because left is add 3 times. Fill those in with zeros. My new answer looks like that. Now remember, the zeros in front do not count, so that's only 3 significant figures, and over here we still have 3 significant figures. So it's always going to have the same amount of significant figures. All right, so let's say we're dealing with some numbers that are not in proper scientific notation. And you might be tempted to leave numbers like this because they're in scientific notation, they're just not set up right. The problem with this number is it's not a number between 1 and 10. It's 45. That's greater than 10. So I need to move the decimal so that I can make this a number between 1 and 10. So I'm going to move it 1 place to the left. Okay, and that'll be 4.5, and 4.5 is a number between 1 and 10. Well, what happens to my exponent? Because I moved the decimal, I have to change that exponent. Remember, left is add, right is subtract. And so I moved it to the left 1 time. So I'm going to have to add to my exponent a 1. So this is 4.526. 2 plus 1 is 3. The significant figures are both the same. It's just now I've moved it so that I've got a number between 1 and 10. All right. I thought I was going to say something else there. Never mind. All right. So I've got this number here with a negative exponent, and it has all those zeros in front. That is not a number between 1 and 10. So we need to fix that. I need to figure out where am I going to put that. I'm going to put that between the 5 and the 6, because then I'll have 5.6, and 5.6 is a number between 1 and 10. So let's move the decimal over till I get there. Okay. I moved it over 4 times to the right. Right is subtract. So let's figure out what this new exponent needs to be. It's going to be 5.61 times 10 to the negative 3 minus 4. And so that's a negative 7. So careful there. That was negative 3 minus the 4 by moving it to the right. Gave me negative 7. All right, let's try another. Here we've got a large number. We're going to move the decimal over till it gets behind the 7. I've got there in that location, I'd have 1 non-zero to the left. I'm going to move it over 2 times to the left. Left is add. So that's going to be 7.8925. All of those numbers stay because they're significant to begin with. And then it's going to be negative 4. Left is add plus 2. So that's going to be a negative 2. Again, that was negative 4 plus the 2. I added the 2 because I moved it to the left, and that became negative 2. All right, so again, we're going to write it in the form like this. That's got to be a number between 1 and 10. Cannot be 10. It can be 1, but it cannot be 10. And this is a whole number. All right, so let's try the calculation part of this. Here are the rules. If the exponents are the same, we can simply add or subtract the numbers in front and then bring down the exponent unchanged. Well, this example has exponents that are the same. So we just add 4 plus 3, that's 7, and bring down the times 10 to the 6. So those are some easy ones. What about this one? Exponents are the same. 4 minus 3 is 1, because the same holds true for subtraction. 1 times 10 to the 6th. Easy, right? Well, what happens if they're not the same? Of course, right? So here we go. This one has 10 to the 6th and 10 to the 5. The exponents are not the same. So if they're not the same, you're going to have to make them the same. You're going to move the decimal to do that. All right, so a hint for you is to always move the decimal in the smaller number. So which one is smaller? 10 to the 5, or look here, the exponent, to figure out which one's smaller. 10 to the 5 or 10 to the 6. So 10 to the 5 is definitely smaller. So it's 1 times smaller than the other one, than 10 to the 6. So I'm going to move this to the left. Okay, why did I want to move that to the left? Well, my exponent now is 5. I want it to become a 6, so I need to add 1. In order to add 1, I have to think, okay, well, left is add, so I have to move the decimal to the left, and that'll bump my exponent up. So I'm going to rewrite this, and you should do that too, because we have to line it up for significant figures. So rewrite it. All right, so 4 times 10 to the 6. Now I've got 0.300 times 10 to the 6. I'm going to add them now that they have the same exponent. And there's my answer. In terms of significant figures, so this has 2 places past the decimal. This one has 3 places past the decimal. Since we are adding, I am only looking at place value. Okay, which one has significant figures in that place value? So 2 places past the decimal is the least. So my answer needs to have 2 places past the decimal. All right. Here's a problem for you to try. All right, now I'm going to work that answer out. You should have moved the decimal over 2 times. The smaller number is the 10 to the minus 6, so I wonder if that tripped you up. It's because it's a negative exponent. This is a smaller number. Okay, so move it over 2 times to get to -4. Think about a number line. Bump it over 2 times, you get to -4. Line it up. Add the decimal. Add them up. Then we say, okay, well, this has 4 places past the decimal. This one has 2. 2 would be the least. And so I'm going to cut it out at 3.50. The 3 cannot bump up the 0, so it's just 3.50 times 10 to the -4. All right, what about multiplication and division? In multiplication and division, well, actually, let's just talk about multiplication. First, you're going to multiply the numbers in the front, and then you're going to add the exponents. So multiplication, add exponents. So we'll multiply these two. 2 times 3 is 6. We will add the exponents. So we'll write just 10 to the what power? It'll be 10 to the 12th power, the 6 plus the 6. In terms of significant figures, we're looking at multiplication, which is not place value. It is least amount of sig figs. So 2 and 3 both have one significant figure, and 6 has one significant figure. Okay, here's another one. Here's a division. In division, you divide the numbers in front and then subtract the exponents. Okay, so here we go. 4 divided by 2 is 2. Then we'll write times 10 and subtract these exponents. So that'll be 6 minus 3, or 2 times 10 to the third. All right, every once in a while you're going to have some that when you multiply or you divide, you're going to have a number that is no longer in proper scientific notation. That is why I spent some time on the video just going over fixing things into proper scientific notation. All right, so here's what you will do. If that happens, you're going to move the decimal to adjust the exponent, just like before. All right, so this one is a multiplication problem. We have 5 times 2, that's 10. I'm going to write that with the same number of significant figures as the least precise one. Well, number of sig figs, excuse me. Those both have 3, so I'd write 10.0. And then this is multiplication, so we'll add these exponents. So that's times 10 to the 17th power. All right, so then what is wrong with this number? Well, I said it has to be a number between 1 and 10. It can be 1, but it cannot be 10. So we're going to have to move the decimal. I'll move the decimal over to the left, and then we'll have 1. Moving it to the left, well, let's go back to our Lars. Left is add, right is subtract, so we're moving it to the left. So I'm going to add to the exponent 1. So my final answer would be 1.00 times 10 to the 18th. Okay, here's the last example. Okay, this time we're working with division. We'll divide the numbers in front. 1 divided by 2 is 0.5. Then we'll subtract the exponents. So that'll be times 10. And I wrote this one out because I need you to be careful. It's -3 minus a -5. When you are subtracting a negative, that's like adding. So really this is going to be 0.50 times 10 to the +2. Okay, so remember, these turn into positive when you have negatives next to each other. All right, so I have to move the exponent, I have to move the decimal so that I have a number between 1 and 10. 0.5 is less than 1, so I'm going to move it over 1 time to the right. I go back to my mnemonic and I say, okay, well, left is add, right is subtract. I moved it to the right, So instead of this being times 10 to the second, what my final answer should be is 5.0 times 10 to the first power. Okay, that's now in proper scientific notation. Now, normally I wouldn't have you keep this in scientific notation because it's really, I could just write 50. But for the purposes of practicing scientific notation, we're going to leave it as 5.0 times 10 to the first power. All right, so that concludes the notes. Hopefully you can ask them for some help, more examples if you need them.